All right, welcome to day 3 of Advent of Code. We are a couple minutes late starting today, but that's fine because this year there are no global leaderboards anyway. One thing that's probably worth noting before we begin with day 3 is that I did continue to do a couple more implementations, specifically the non-toString or non-allocating solution. So for part 1, we used strings and string slices, which allocates a string for every ID. I then swapped that to use an ilog-based approach with div and mod, and then I put Rayon on top of that. Overall, this is still slower than other people's solutions that I've seen, so we're still running in about a millisecond here, 6 milliseconds for processing all the IDs, but still about 10 times faster if you round this up to 50 between part 1 with the strings and part 1 with the ilog, which is a good improvement. So that code, of course, is in the repo. This is the entire thing if you want to pause the video and take a look at it, but let's create day 3 and get started. Day 3 is lobby, where we descend a short staircase, entering a surprisingly vast lobby. All the elevators have a red light and they're all offline. The elf apologizes. The escalator is also offline. The funny part about this is escalators can't really break, they just turn into stairs. So we could just walk. So it needs power the escalator while the elf works on the elevators. So there are batteries labeled with their joltage rating. I don't know what a joltage is. Joltage is a callback to 2020, which is a similar battery problem. So this is a value from 1 to 9. You make a note of the ratings. Is this 4 batteries? So each of these is a bank. Each line is 1 bank. Within each bank, we need to turn on 2 batteries. So each of the numbers is a battery. The joltage the bank produces, which is the entire line, is equal to the number formed by the digits on the batteries. So if it's 1, 2, 3, 4, 5, and we turn on 2 and 4, the bank would produce 24 jolts. We can't rearrange the batteries, which is good to know. You'll need to find the largest possible joltage each bank can produce. So that's min-max, right? No, it's not min-max. It's the biggest number and then the biggest number of the slice after the biggest number, right? So in this case, it's 98 because that's right at the beginning. And here it is 8. And then the biggest number in the rest of the slice is 9. We can't use the last one as the first value because otherwise we wouldn't get a second number. So basically this is checking just this for the max. And then wherever that max is, checking all of the rest for the next max, right? So that would be max up to here, which is 7, and then 8. And then this is max up to here, which is 9. And then the max of the rest is 2. So 2 maxes, excluding the endpoint. So it seems pretty straightforward. So let's get started. The answer here is going to be 357. So it's the sum again of all of the individual numbers. I think these actually sort without parsing. So if we take our input, get rid of this for a moment. So if we take our input and we do lines to get each line, this is a bank. I want the position of the max. I don't know if we can get the position of the max directly. We can get the max, and we can get the max if we enumerate. So we can probably do max by or max by key. So if we do cars dot enumerate, which gives us the index of each of the characters, and then we max by, and this is going to be index battery, and we want battery here, and we want this to be without the last one, so we probably want to do the slice of bank length minus 1. I have a syntax error here because I started writing let, let's see, index max equals this. And then I don't have my to-do here anymore, so we're getting a bunch of type inference issues. So this will have to exist. If this doesn't exist, then we are in big trouble. I named this batter instead of battery. This takes multiple arguments. Max by takes 2 arguments. Max by key is what I wanted. I want max by key. And then this is going to be a reference to a character. So I think we can dereference that. And then this outer needs to be a sum, and we'll just sum into something big like a U64. These are no numbers yet, so we'll just throw a 0 in here. And I should be able to debug index first max if we cargo test P day 3. Let's make sure we're doing only the part 1 tests. Does it say we haven't built the test yet? Because I left the to-do in there. Of course I did. So we end up with 9, 8, 7, and 9. Are those the right numbers? 9, 8, 7, and 9. Those look like the right numbers to me, which is great. And then I believe our next step is basically the same thing. Let's copy this whole thing, actually. This is, I guess the second index doesn't matter. And this is the second max. And this is going to be a range from index ... I guess this is index plus 1, really. Because the start of this is always going to be included. We don't use these indexes in our max by, but we do need them later. I don't know if we're going to need these in part 2, so I'm just going to kind of leave them here, even though we could totally get rid of them at the moment. So we end up with first max, let's say plus second max. This is not the right way to create a string. So in Rust, if we want to create a string, a really common way to do that is to use the format macro. So we end up with first max, second max with these 2 variables. And we will just debug that out for the moment. And we should end up with 98, 89, 78, and 92. 98, 89, 78, and 92. Those are all the right numbers. So really all we need to do here is parse U64 unwrap because this should just work. And I'm summing and not returning. Let's get the result here. And let's keep this semicolon. And we'll do result.toString, which if you have Rust Analyzer, you can do .ok and hit enter, and it'll wrap that expression in OK for you, so you don't have to go back and forth. And that, I made this mistake yesterday of claiming the test passed with it when it didn't run. But the test is passing. So day 1, no, not day 1. Day 3 bin 1 is this number, which hopefully is a gold star. That's not the right answer. Okay, cool. So we did something wrong, or our input is different. Our test passes, so that's unfortunate. Did I make a mistake with what the puzzle input is? The puzzle input is pretty large. The index might be off. I might have done the instead of doing a +1 here. Basically, in this case, we now have to figure out which of the inputs has a condition that we didn't account for, which is really unfortunate. So maybe I do a debug assert here for this, and just say that we debug assert that this is not empty, basically. So because we're running in debug mode, that will theoretically, if this were empty. So if I overrode this, right, bank equals like string slice here, that would panic here with byte index out of bounds, unfortunately. Let me paste this just to demo it. So see that the assertion fails on bank is empty. If we get rid of this, then all of these should pass because I think they all have something. So when we, this is a macro that Rust provides, and it's important that these are only enabled in non-optimized builds by default. We have a non-optimized build. So this debug assert basically ensures that this is true when we run without optimizations, but if we run with release mode or something, this debug assert won't exist. So just a sanity check to make sure that we don't have anything empty here. The issue here is string indices are ranges of usize, right? I thought I tried this before. Oh, because it's a reference. It's a reference. So that doesn't change our answer, actually. 17212. So there's something here that the test input doesn't actually cover. So the question is, what is the problem? We need the total output. We're doing that. We need the maximum joltage possible, which is the maximum value we can find, right? And then the other maximum value we can find. I think it doesn't matter what order we do this in, because if we do, maybe it does matter what order we do it in. We need the tens place to be as high as possible. So I think what we're doing is correct there. Maybe we print these out and take a look at them. We can't rearrange. I think these are long enough that they basically always come across a 9 of some kind. Not all of them have 9s, but a lot of them have 9s. So like this one would end up here and be 95, and that would end up here and be 92. Unfortunate. I don't think there's anything I missed. We need to turn on 2 batteries. That's what we're doing. Equal to the number formed by the digits on the batteries we've turned on. We always find 2 numbers. We are summing them all together. This is just completely the wrong answer, which is great. Did I run the right program? Cargo run day 3, part 1. We are in day 3, part 1. Okay, I do not know. We're going to have to figure it out. If we test day 3, part 1, we run the test passes. So, are there zeros? There are no zeros. Does max give us the last match or the first match if there is a duplicate? Let me replace this for a second. It will fail. So let input equals, let's say like 8, 9, 7, 7, 7, 7, 7, 8, 9, 7s. I don't know, something like that. If we run this test, then we end up with no logs because I removed them all. Let's say info, index, first max, second index, second max. I'll name this second index. Pull this in from tracing. Wonder why that's giving me an issue. Unsatisfied trait bound. Value is not satisfied for car. Okay. So first max, second max. Both need the bug sigil. Okay, so we end up with nothing because I didn't set up my test correctly. I want test log test. And then we get our index of 11. So 0, 1, 2, 3. It gives us the last one. We need the first one. Unfortunate. If several elements are equally maximum, the last one is returned. That's not really what we need. We could do another search, another scan through these, and it wouldn't be that much of an issue. But I do want to check if we have another option. I think that itertools has max set, and max set should give us all of them, in which then we take the first one. And I think keeping them all around is fine. So what? Max set by key? Max set by key. I guess it doesn't matter for the second one. This is going to come from itertools, which we're going to pull in. This is an extension trait, so it's adding more functions to iterators. This is no longer returning an option, it's returning a vec. So let's do first here, and then we can unwrap. And then this is what, a temporary? You know, at some point you write enough Rust that you recognize when things are supposed to live or not living. Okay, so this chunk here, we're grabbing a reference here to that value, but this slice is not living long enough. So we have 2 ways to fix this, really. We could set results up here like this, and then do results.first.unwrap, which stores this vec into this variable. So variables in Rust, or values in Rust, data has a single owner. And then results.first gives us this character reference here. So this is option 1. Basically, what's happening here is we're creating this vec using this iterator. And then I'm also trying to grab a reference to one of the items. But the other option here is to just clone the value. So if we want to create that vec here, grab first, clone the value that we grab from the first, and then unwrap, that vec can drop at the end of this semicolon, and we don't need it anymore because we cloned the value. So let's make sure our test passes, and that we're running the right test in the first place. Let's see. This gives us index 1, first max 9. So 0, 1. And then I think we do actually want I plus 1, which I removed earlier from our index over here, right? Because we want to start at 2. We don't want to include 1. So let's get rid of this. Let's uncomment this. And let's test this, assuming that I... Let's test this. That passes. Cargo run, part 1. 17,427. That is at least a different number, which is good. I think a higher number makes sense here, because theoretically we should have more occurrences where we get basically like a 9 and a 9. The question here I have is, before, there's no example here of like a 99. It doesn't say that they need to be unique, but it is possible. So that's the right answer. Perfect. So that was our mistake. Our mistake was basically grabbing the last max instead of the first max. So let's get rid of a little bit of that stuff and then move on to part 2. We just kind of covered part 1. What we're doing here is using itertools, which extends iterators with additional functions. We're using max set by key to get that vec of all of the max values. In this case, we just want the first one. So this is behind the scenes creating a vec. We then want to clone that inner value and unwrap it, which gives us the values that we want here. And then it doesn't matter for our next one. We can just do max by key. I guess theoretically, we could short circuit here too. If we ever saw a 9 in the second iteration, we could always stop at that 9 because there is no bigger number than 9. But other than that, we just throw these things together and parse them and add them. So part 2, the escalator doesn't move. Probably needs more joltage to overcome the static friction, and hits the big red joltage limit safety override button. You lose count of the number of times she needs to confirm, yes, I'm sure. We need to make the largest joltage by turning on exactly 12 batteries within each bank. Now there will be 12 digits instead of 2. So basically we loop over and do this 12 times. Voltages are much larger, obviously, and the total is much larger. So let's grab everything we have here and see if doing it like this is fast enough to actually solve the problem or not. The question here being, let's see, let batteries equal vec. This is going to be a vec of cars. They said we have, 12 numbers now? So let's just take a brief second to check to make sure that 12 is fine. And a U64 definitely holds it, so we're good. And then I think this is just loop over, find the first one, loop over, find the first one, 11 times, right? So 0 to 11 should get us 11, and then this will get us the other one. We need to keep some state while we do this. We want to batteries.push first max. We want to basically do this instead. The question here is, do the subsequent iterations that we have to do here, do they also skip the last one? I think they do, because we need at least one number. So the question I have here is, does this skip the last 12 numbers? Because we can't have a max that is inside of that. So I think that's accurate. I think this number has to get tracked as well. And this is basically going to be 12 minus I, right? And we're going to go from current index, which is going to be let mute current index equals 0. I guess we don't need a mute for the other thing. I am going to clone these cars out instead of using references, or copy them rather. I'm dereferencing, which is an implicit copy for the character here. We want to go from the current index, which is 0, to the length minus the rest of the number spaces. So for the part 1 answer, this would be -1. For our answer, this is -11, right? If we find 1, we need at least 11 more spaces. So this is going to be 11 minus I, because this is going to go from 0. So 11 minus 0 is bank minus 11. That gives us 11 spaces to fill other numbers in if we need to. And the index becomes the next current index, right? So we get current index equals index plus 1. Because remember, we were doing the plus 1 in the next one here, but we don't... I guess we technically do have the opportunity to do that. It's kind of a matter of where do we actually want to handle this. I'm going to leave it like this because we're going to start with 0 and I don't want to modify 0, and then I'll add 1 to just give us what we should be at next time we do this. And I think that's going to be okay. And then we will get rid of this debug assert for now. We don't really need it. And this is going to be current index. We got to also do the plus 1 here. And then we need to format and concatenate all of these characters, which instead of using format, we are going to do, what do we call this? Batteries? We're going to collect. I guess we could just do like direct character to number. But I think this is cool too. So if we iter, we can collect all those characters into a string, parse them as a U64, and then sum everything up. So if we test part 2, and I remember to specify batteries as mutable in the first place, then we have failed, which is why. Because we didn't add second max to our batteries. Batteries, I'm just going to push it in here. Unwrap on a none value. Oh, okay. Part 2, 22. Where's 22? 22 is here. We have to find something here. So the question is, when does this break? This is going to be I, and I guess let's also log out bank and bank slice, which is going to be this. Am I missing something here? Bank. I have extra brackets. That's what I have here. And then we'll use the debug sigil. We will test. We will take a look here. And we end up with 0, 1, 2, 3. 9876 is a weird slice to have, right? I guess if we are at 0, then we have to just take everything. Is that accurate? 9876. How many numbers are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15 numbers. So this is supposed to be 9876 5432 1111. And we are operating on our slice, trying to find the max. Bank.length is the wrong number, right? Because it needs to be the bank slice.length, effectively. That's annoying. So do we do bank length minus current index minus 11 minus I? Current index is going to be 0, 1, 2, 3, right? So 0 here. So it's going to be minus 0. 1 here. I think we need to add current index here. Again, no. What do we need to do here for the indexing? We need to do, the current index is moving forward. This needs to be from the very end. So let's do bank.length, oglen, and then new length. These are for the indices. So we need the index, which is length minus 11 plus I, which results in the wrong number. Let's skip the input on instrument. So bank is 9876. This is a length of 15. We need to be looking at the first 4. Why does the length, why does it stop here? Am I not updating current index? No, I am. Index plus 1. This index is the one returned. Let's do like index found, and this is first max. So we have 9876 found at index 0, number 9. 8765 sounds like the right next step because we found one, so we're still a length of 4. Index 0, first max 8. Oh, that's our issue. Index comes back as the index. Okay. So it's index, current index plus 1, where index is potentially something else, right? I guess not, because why? This is the index of the slice. So this is how far ahead we have to move. So I think it is current index plus index. So 9876, index 0, first max 9. 8765, 0, max 8. 7654, we find 5, 4, 3, 2, 1, 1, 1, which seems to work overall. And then we end up with option unwrap on a none value for this one. I is 10. The full bank is this. We're at slice 7. We could shortcut if we hit the limit. What's the number for 234 supposed to be? 43423. So here, 43423, 423427, 423427, and then 8. So we missed the last one, right? Is this unwrap is happening here? So we don't do a +1 here. I think that feels weird, but we can run part 2 since our test passes and see if we have the right answer at least. That is the right answer. Okay, we're done. Okay, I guess let's get rid of some of these infos since we don't really need them anymore. And what we're effectively doing here is starting from 0 and going up. We take the full bank, we slice out the front segment. So this is a length of 15, which means that we can only choose between 4 characters for this max. Once we choose one, we can move that index down 1, which gives us 5. And then actually we found the first one, so that gives us 9. I think the indexes here are basically always 0, but if we find a 2, so here we have this 4 gets found, right? So our next slice needs to be starting at this 2, which it is, and you can see that it gets shorter because we've skipped 2, we found 1, so that means we need to move forward 1 and drop 2 from our gap, which means that we had 4 characters before, and now we only have the option of 2 characters. If we ever hit a point where we only have 1 character choice, we could write a special case to just iterate over the rest and add them, right? Because if we hit a situation in which there is only 1 character left, then this whole computation is just going to keep finding the next character. So overall, we have our input, which is each of the banks, right? So this input is, if we go back to the actual problem here, each of these 4, we'll say, this is a bank, this is a bank. Each number in here is a battery. So we iterate over each bank. For each bank, we keep track of the current index and the number of batteries we've found. The batteries we've found are the max values. The current index is just the next place we're going to start our slice of the bank. So the bank slice is doing a lot of the heavy lifting here, and then max set by key is doing the rest of the lifting. Our slice here is giving us a window into the bank for the only characters that we are allowed to choose from. This is true because if you have 11 characters to choose and you have an 11 character slice, you have to choose all 11 characters in order. There is no other option. If you have 12 characters to choose from and you need to choose 11, then you can skip at most 1. So that's why when we iterated over and we see the iterations, that we see 4 characters here, because all of our test values are 15, which means we get to skip up to 4. So given the string that comes in, or the string slice that comes in rather, we can go from 1 index to the end of our viable range to choose from. When we do that, we use cars to get an iterator over each of the individual values in that slice. We enumerate them, which gives us the index in the slice that we are at. So enumerate is why we get index here. Max set by key comes from itertools. Itertools is an extension trait. So anything that implements iterator also gets these functions from the itertools trait. If you import the trait, you have to import the trait. You have to bring it into scope, that is, for the itertools trait to add those functions to anything that implements iterator. This is called an extension trait. So we use max set by key on our iterator of characters with indices. The max is, it's just the max character. Because we're only dealing with numbers, the order of numbers and the order of the characters that represent those numbers are actually the same in terms of the sorting. So the character 0 will sort before, or rather, the character 0 will sort as less than the character 8, similar to the number 0 sorting less than the number 8. This just happens to work out, so we're relying on that property here, which means that we don't need to convert between characters and numbers at all. Once we do that, this creates a vec. So if we look at max set by key, returns all maximum elements of an iterator as determined by some function. You can tell from the return type here that we're getting a vec. So this is looking for all of them and then creating a vec and giving it back to us. This is true for all of the max set or max set by functions. So from that vec, we get the first one. If we look at the type inlay, we can see that first gives us an option of a reference to this tuple, which is the index and the character. If you go to option, there is a method called cloned, which maps that shared reference to the tuple that we have into an owned value by cloning the contents. So here we are cloning these characters, or we're copying these characters, and then we're cloning the characters again, which also calls the copy. So we get those values, and then we unwrap that option, And we end up with the index in the slice specifically, not the full bank slice, but the slice that we are looking through, as well as the max value. So we push that max value into batteries. We copy it again because I don't really think it's worth using a shared reference here. And then we set the new current index, which will be our index inside of the full bank, to the current index plus however far we moved forward, plus the next one after that. And we do that 11 times. And that should give us 11 values. And then we have one more to do, which is just whatever the max value of the rest of the slice is, that's the one that we push in. We iterate and collect that into a string and then parse it into a U64, which is not terribly efficient, but we really don't have that many numbers to do here. If we had a longer list, maybe it would be more important. We then sum all of those values that we parsed into U64s, and we have that as the result. So that's it for today. Let's do a cargo bench. And this is 60 microseconds and 240 microseconds. So realistically, I don't really feel any need to optimize this at all. It's possible that there are places where we could, but I'm pretty happy with microseconds for an advent of code solution, so I'm going to leave it at that, and I will see you tomorrow. Have a great rest of your day.